All right, so today we're going to have a look at pairs of uniformly varying motion. Basically what this is a set of parametric equations, but those parametric equations are going to be linear. They're not going to be quadratic or cubic or anything larger. They're going to be linear, so they uniformly vary with each other. So we're going to have a look at an example first. I think that's the best way to look at this stuff, just jump straight into an example. So we've got a particle, it's parametric, you can see represented here. The x and the y are both changing in terms of t, and it moves with these parametric equations. So x of t equals 2 minus 3t and y of t equals 2t plus 4. It's all greater than or equal to 0 seconds, and the distance is in meters. All right, question 1, find the initial position. So the initial position happens at, so we're doing part A. The initial position happens at t equals 0. Therefore, if we substitute t equals 0 into our x of t, x of 0 equals 2 minus 0, so it's just going to be 2, and y of 0 is going to be 2 times 0, 0 plus 4 equals 4. All right, therefore, initial position is going to be 2, 4. All right, so pretty standard. I expect we could have done that before this example. And secondly, find the velocity vector. So remember, the velocity vector is how it's moving. All right, so that's really important in terms of t. So for our x value, the thing that it's changing by every time is -3. So -3 is how it's moving in the x, and on the y it's moving with 2. So what you do is you just have a look at the things in front of the t, and you put them in, and that there is the velocity vector. Cool. So that's the first couple. We'll have a look at a few more now. All right. So the same question. We want to go have a look at the illustrate the motion for the first 3 seconds. So we're going to draw a table. Now we could put it in Cartesian form, but we're just going to draw a table and y for the first 3 seconds. So 0, 1, 2, 3. So at 0, if we put into our 0 into our x, we're going to get 2 minus 0, which is going to be 2. We put in 1 into there, we get 2 minus 3, which is -1. Put 2 in, 2 minus 6, which is that right? 2, yep, minus 6, which is -4. And 2 minus 9, which is -7. We do the same for our y. Put in 0, we get 4. Put in 1, we get 1 times 2. 2 plus 4 is 6. We're actually going to see a pattern because it's a linear equation. It's just increasing by 2 every time. All right. So if we want to illustrate this, if we want to graph it, we're going to start at our x ranges from 2 to 7, -7, and our y goes from 4 to 10. Okay. So let's draw this axis. That's going to be 2, -2, -4, -6, -8. And we're going to go 2, 4, 6, 8, 10. Obviously, this looks better if you've got a ruler. So put the points on there. We're going to get the first point is 2, 4. So 2, 4 right here. Next point is going to be -1 and 6. So about here. And we're going to get -4 and 8. -4, 8. And -7, 10. All right, so what you see is we get a linear, not quite linear, but we get a straight line there. And that's why this topic was called uniformly varying motion, because it creates linear or straight line graphs. All right, so that's the graph, and that's part C done. Now let's have a look at part D. So part D, we want to find the speed. So what we know already is the velocity vector was -3, 2. So the speed is going to come from there. So the speed is equal to the square root of each part squared. So -3 squared plus 2 squared. So we've taken that straight from the velocity vector. Square root of Negative 3 squared is 9. 2 squared is 4. Equals the square root of 13. And we know the units in meters, so we can say meters per second. All right, excellent. And that's part D. Part E, we want to find the Cartesian path. Let's see if I can sneak it in down here. So we want to do part E, find the Cartesian form of it. So we've done this before. We want to find firstly x in terms of t. So if x equals 2, take 3t. We can take 2 to the other side and divide by negative 3. We get t equals x minus 2 divided by negative 3. All right. Now all we need to do now is substitute that back into the other side. So into the y. So y, y equals 2t plus 4. Substitute in our t. So we get 2 lots of x minus 2 over 3 plus 4. We can simplify that, or we can leave it as is. But yep, we have done the last one as well. So that's an example of uniformly varying motion. We'll have a bigger look next time at non-uniformly varying motion. Thank you.